So in this particular computer output, this was from a class experiment involving paper helicopters, and we were looking to see if there's a linear relationship between the height a copter is released from and the time it takes to hit the ground. So we just need to work our way through the different things in this picture as far as what's going on. First, the two coefficient places, those are the pieces of our regression equation. Remember, our general structure is y hat equals a plus bx, and a is the slope, or y-intercept, and b is the slope. Well, the coefficient, COEF, that's where our slope and our y-intercept come from. The coefficient that comes from the constant line is the y-intercept. And the coefficient that comes from the other line, which usually has something from the problem, like here it's drop height, because that was the x variable. But the other coefficient is the slope. If we look at the rest of the line that the y-intercept is, the rest of that constant line, none of the rest of the things in that top line are used. So this SE coefficient, T and P, we don't use those because we're not doing anything else with the y-intercept. So those we can completely ignore. If we go down to the other line, the line that has all the slope information, this next value, next to the slope, that's under this SE coefficient line, so we're looking at this value right here, that value is called SEB, which stands for the standard error of the slopes. We'll talk more about what it means in terms of what you have to actually know about it in class in the next lesson. But here you just need to know that that's the SEB value, and we'll need that in when we get to our formulas tomorrow. Next to that is actually information about a significance test for the slope. They've already run the test. That t value there is the t we would use in a t-test. So this one is gigantic, a t of 28.37, that's like a z-score of 28.37. That is unbelievably large, which is rare, but it can happen for unusual sets of data. And then right next to that, the p there is a p-value. The catch is it's the p-value for a two-tailed test. It automatically is set with an HA of beta not equal to 0. So if you're doing a one-sided test where you want to look for a positive or negative slope, you would just need to divide by 2 to get just the normal p-value for a less than or a greater than. But again, we'll talk more about that with the test. But that's the p-value. This t here is not a t-star. You would still need to look that up from your t-table like normal. This is the t you'd get from a significance test. Now in that bottom line, right next to, or right here, this r squared adjusted, that one we do not use at all. We do use the r-SQ, that's our r squared value for the data. And then this last value, this s, that s on the bottom left corner here is the standard deviation of the residuals. So that wraps up the computer output. Again, we'll actually talk about doing significance tests and confidence intervals in the next lesson, but that at least sets you up for your P and your A step as well as reading this computer output.